Good morning, my dear friends. In the last class, we were seeing something on this how to design this PSC sections, okay, especially for flexures, like say it may be PSC beam or PSC slab, okay, and we have used Lin's method of design, okay. So now under that Lin's method of design, we have got two things. One is preliminary design, and another one is final design. Am I right? Two steps are there. So in preliminary design, in the last class, we have seen so many thumb rules and so many equations by which I can do my preliminary design. In the sense, in my preliminary design, what I am going to do is by using the equations, whatever you have seen already, okay, I am going to fix up roughly the approximate cross section. Say, take for example, okay, I want to design a rectangular beam, okay. So by using these preliminary design rules, I can fix up the breadth B. Am I right? We have got various thumb rules, and also I can fix up the depth D also now. Okay. Once you know D, B, and D, okay, you can easily you can fix up YT, and you can easily fix up YB also now. Am I right? So now, in a sense, B, D, YT, YB can be easily fixed. And by knowing this, even you can calculate your AC also. Am I right now? AC, or you can even calculate your moment of inertia also. Okay. So now all these things can be fixed in your preliminary design, and to some extent you can even calculate the approximate the initial processing required and approximate effective process required, okay. By using various these things, you can do all these things now, okay. But whatever you do here now, it is all approximate, okay. It is not at corrected values, they are not correct values, or they are not final values. So now in the final design, okay, what we are going to do is now we are going to fix up all these things accurately, okay. So my dear friends, here in my final design, we have got three different cases. One is design by allowing no tension in concrete, okay. Then second is design by allowing but neglecting tension in concrete. And the third one is design by allowing and considering tension in concrete. Okay. So now, as you know, Banu, since tensile strength of the concrete is very, very less. Okay. So what we do is now we don't allow tension in the concrete. So now first case is more popular. So now you got problems only in the first case. In a sense, design by allowing no tension in concrete. In a sense, I am not going to allow any tension in the concrete. Okay. So now we are concerned only with the first case. These two B and C, we are not going to concentrate much upon that. Okay. So now we'll take up now the first case now. Okay. Design by allowing no tension in concrete. In the sense, I am not allowing any tension in the concrete, either in the initial stage or in the final stage. Okay. So now here you can see the figure. If you see the stress distribution diagram, okay, sir, now I am not allowing any tension to occur either in the initial condition, your tension is 0, or in the final condition, tension is 0 at the bottom side. So I am not going to allow the tension in concrete. That is what my first case is now. Okay. So now again, when I take up this first case, here I have got now two different cases again now. One is for small ratios of MD by MT, and another one is case 2 is for large ratios of MD by MT, where MD is, Baba, it is the dead load moment, and MT is the total moment. Dead load moment divided by total moment. This ratio, okay, if this ratio is small, okay, then it is called case 1, and if the ratio of MD by MT is large, then we call it as case 2. So now we shall see in detail case 1 and case 2. So now, as you see, case 1 is if the MD by MT ratio is small, okay, that is If MD by MT ratio is less than 0.2, then I will call it as small ratios of MD by MT. Okay. So my dear friends, now we shall try to see how to solve this design, this thing now. Okay. So now as I have already said you, okay, from your preliminary design, you can fix up a breadth B, depth D, YT, YB. Okay. And once you know these things, you can easily calculate your AC, in sense area of concrete and moment of inertia. Am I right? And also from your preliminary design, you can even calculate your F naught and Fe. In sense, F naught means it is the initial pre-stress and Fe means it is the effective pre-stress. Okay. You can do all these things now. Also, now, when once you know these YT and YB, even now in your preliminary design itself, you can calculate your KT and KB. Am I right now? Because your KT and KB values can be written as, okay, uh, R square by YB, and this is R square by YT. Am I right now? These are the two equations. It is the upper current distance KT and this is your bottom current distance KB. Baba, about this current points KT and KB I have already discussed with you in my last chapter itself. Okay. So please refer this KT and KB. KT means it is the upper current distance and KB means it is lower current distance. Okay. So R square by YB will give you KT value and KB value is R square by YT. Okay. So now even from your preliminary design, I can even calculate your KT and KB value also. Okay. So now, my dear friends, now let us try to now see this thing now. Okay. See now here I have taken up this thing now. So the same thing I have written for the section obtained from preliminary design. The values of MD, KT, KB, AC are computed when the okay, they can be easily computed. Okay. So now let us try to analyze this problem now. Okay. See now. So now I have taken a general section here now. Okay, assume that it is a T section, a generalized T section. Okay, so now I have fixed up here the breadth B, excuse me, the overall depth D and breadth of this. Okay, and breadth of this web, breadth of the flange also I can fix up, and breadth of the web also I can fix up by using your preliminary design. Okay, so now once I know this, but now I can easily fix up my CGC also now, because since it is not a symmetrical section, okay, I have to fix up my CGC. Okay, I can do it very easily, this one. So once I fix up this CGC, I can write my YT value and I can write my YB value. Is it right now? So CGC is fixed. And also now I'm going to put here some precessing steel here now. Okay, so I can mark here my eccentricity E now. Am I right? I can mark here my eccentricity E. Okay, so now also, as I have already said you, I can even calculate my value of KT and KB. In the sense, KT and KB means, okay, here is a point, okay, wherein in the final condition, your C force should not act beyond this line or beyond this point. If it acts beyond this point, okay, in your final condition, okay, your bottom fiber stress will exceed the allowable tensile value. Okay. Similarly, here I have got one more point which we call it as bottom current point. Okay. So now I don't allow my C force to act below this. If it acts exactly here now, my top fiber stress will reach zero tensile stress. If your C force acts below this, okay, you will see that your tensile stress in concrete exceeds your permissible tensile value. Okay, so but now here I should not allow my C force to act beyond this point or beyond this point. Oh, sir, now your C force should act only within this range. Then only I can assure you that the tensile stress do not exceed its permissible value, or it will remain zero. Okay. So with this, Baba, now I would like to tackle it further in my next class. Thank you very much.